Alrighty, so this is where we were yesterday. Let's just recap a little bit here. So we have rocket A has a positive velocity. We have a chart. It's being launched upward. We have our initial height. So we have this that we might need at some point. Velocity of the rocket is recorded. Okay, so on A, we found the average acceleration, which is acceleration is the rate of change of velocity. We were able to find that just fine. Then B says, using correct units, explain the meaning of this in terms of the rocket's flight. And then we're supposed to use midpoint rectangle. So we didn't have time to write that stuff down. But when you remember that anytime you have an integral, you are finding accumulation, okay? How much stuff has changed. And so when I integrate velocity, I get position. And if we're looking at change in position, then we are looking at a distance, right? So when I integrate velocity from 10 to 70, that's going to give me the total distance traveled of the rocket in that time. Does that make sense? So that's what we are going to write for the first part of B. We are going to say the integral from 10 to 70 of v of t dt is the total distance rocket A traveled in, what units are we traveling in? But what unit do we travel in? If I have, how far I have traveled, what would the unit be? It would just be feet. Okay. Yeah. Okay. So the total distance rocket A traveled in feet from t equals 10 to t equals 70. What are the units on our time here? Seconds. Okay. So you have to have all that. You have to set, it even said correct units. We're traveling, like we can't say it's 35 feet or whatever it is because we don't know that, but that is the total distance rocket A traveled, and you can't say it traveled, in feet from, and then the time with the units there as well. Okay. The second part of that, we were supposed to use Riemann sums to estimate it, so we're going to integrate from 10 to 70 of v of t dt, and since I'm using Riemann sums, this is approximately, right? Go back up here, let's reread what it said. Use midpoint Riemann sum with 3 subintervals of equal length to approximate. Okay, and we are not using the whole thing. We are going from 10 to 70. This is how we would break it up evenly, right? So 3 from 10 to 30, that's a change of 20. These should all be a change of 20 because it said equal length, right? And then these are midpoint Riemann sums. So the height of the rectangle is the middle number right there. Highly suggest you circle them or do something so that you use the right numbers, right? Because we don't want to pull the wrong numbers off of the chart. Okay. So this is going to be, now I can't see anything. I'm going to do 20 times what number? 22 plus 20 times what number? 35 plus 20 times what number? 44. Okay, there are 3 rectangles. I'm not going to actually do any more computation, but I need units. What are my units? Feet. You are integrating velocity, which is feet per second. You're going backwards, that makes it feet. Yes? We all good on that? What questions you got? Okay, so then we have C. Let's go back up here and read C. Rocket B, which is different than rocket A, launched upward at this acceleration, And it's acceleration, and it says feet per second, so we got some units there. At time t equals 0, the initial height of the rocket is 0 feet. The initial velocity is 2 feet per second. So that means initial height, that's x of 0 equals 0. Initial velocity, v of 0 equals 2. Right? Which of the two rockets is traveling faster at time t equals 80 seconds? And explain your answer. So what do you think that we need to find? I need to find which, if it's traveling faster, I need to look at the velocities, right? Would I have a greater velocity? Do what? Okay. So let me rewrite. I'm going to rewrite our acceleration since I can't see when I'm down here. Acceleration, a of t, is equal to 3 over the square root of t minus, or t plus 1. Right? So if I take that and I integrate it, then I would get the velocity equation, right? Which is what I want, because I'm going to have to find I have to find IROC. I heard somebody say it. I need the instantaneous rate of change, but that means that I've got to find velocity. So I'm going to need to integrate this, right? And I'm going to rewrite this as 3 times t plus 1 to the what power? Negative 1/2, and you cannot forget your dt. Okay? All right. So I'm going to, when I integrate, technically I should do u substitution because this is not just t, but it's t plus 1. And when I do the derivative, it's just going to give me du, d equals dt. And so I can just let this guy hang out and he doesn't affect anything. So I add 1 to the exponent, right? So I'm going to have 3 times, and when I add 1 to the exponent, what do I get? 1/2. And then I divide by 1/2, which is the same as multiplying by what? 2, right? And then I can't forget a plus c, because I'm not going from like A to B here or anything. So that means what this gives me, because dividing by 1/2, same as multiplying by 2, so I get 6 times the square root of t plus 1 plus c, right? And this is v of t. I need to find c. Do I know anything that could help me find c? I have the initial velocity, and my initial velocity is what? 2, okay? So that means when I substitute that in here, this is my initial velocity, it's 2. That's equal to 6 times the square root of 0, because that means the initial condition, plus 1, plus c. Yes? So 6 times the square root of 1 is just 6. So when I subtract that, I'm going to get c equals negative 4. So v of t equals 6 times the square root of t plus 1 minus 4. Okay, we agree with that? And then what do I want to do with that? Plug it in. What am I plugging in? 80? Because it says, yeah, t equals 80. So v of, oh, and this is actually v sub, this is rocket B, right? So v sub B, yeah. So I can keep them straight. V sub B of 80 is equal to 6 times the square root of 80 plus 1 minus 4. Right? 80 plus 1 is 81. What's the square root of 81? 9. So I get 6 times 9 minus 4, which gives me 50. What are the units? Feet per second. Okay? Well, that's V sub B. How am I going to figure out what V sub A of 80 is? I look in the chart, and what does the chart say? 49 feet per second. All right, so which one is traveling faster? Rocket B. So we still have to answer the question, like, here's your work is kind of your explanation, like I figured all that out, that's where that is, so I really just have to say that rocket B is traveling faster at t equals 80 seconds. Okay. Everybody okay with that? Yes?
At the orange steps at C, we just wanted to make sure you were just integrating it, right? Like you rewrote.
Oh, I rewrote this. I took this and just rewrote it as this. I made this the square root, and 3 divided by 1/2 is really 3 times 2. So it came from here. Dividing by 1/2 is the same as multiplying by the reciprocal, which is 2. So 2 times 3 gives me that 6, and then this is to the 1/2 power. That's where I get the square root from, and that. So from here to here, I was integrating. From here to here, I was just cleaning it up. You good? Okay. Yes, we all good? All right. And I just realized I did not open my calculator. Let me go do that real quick. Alrighty. Here we have this graph. Okay? Karen is riding her bicycle along a straight road from home to school. So she just lives, right at the end of the road or in the middle of the road, whatever. Starting at home at time t equals 0 and arriving at school at t equals 12 minutes. During this time interval, her velocity in miles per minute is modeled by the piecewise linear function. So this is a velocity graph. We label that so we make sure we know what the heck we are looking at. Okay? So if she's starting here, her velocity is increasing, then her velocity is decreasing. What is happening right here? She is changing direction. Since her velocity is positive, she's going, let's say, to the right. Then it's like she got there, she's like, dang it, I forgot my ID and I don't want to get in trouble. So she turns around and she goes back home. So at this point right here, she's back at home. How do I know that? Because these two triangles here are congruent. So if I started home, I went this far, changed direction, and then I'm at home for a while looking for my ID, right? Okay, so I'm at home. I find my ID. I'm going back to school. Her velocity is increasing. She's, so her velocity is increasing, which means she's accelerating. Then her velocity just stays the same. Then she slows down, then it stays the same. And then she slows down and she gets to school. Does that make sense? Okay, so because it's important to understand, that's why you did all those little things in algebra about what, make up a story or whatever. That you need to do that, but understand this is not a time and distance graph, it's a velocity graph, so you got to make sure you're looking at positive velocity, you're moving away from home, you're negative, you're moving towards home. Okay, so I want to find the acceleration of Karen's bicycle at time t equals 7.5 minutes. All right, 7.5 minutes is like right here. So the graph is velocity. Tell me something just by looking at the graph. Tell me something about her acceleration. Is it positive or negative? Negative. Okay, it's negative. And then I can figure out what it is, right? Because since this is even though it doesn't ask for average rate of change, I can do average rate of change because it's just the slope of this little line segment, right? And I have these two numbers here. So let's go to A here. And then I don't like these questions because I can't scroll and I can't see. I'm looking for the acceleration at 7.5. Well, that's a 7. 7.5. So this is going to be, I can do v of 8 minus v of 7 over 8 minus 7, right? Acceleration is the rate of change of velocity. And then what is v of 8? 0.2 minus v of 7, which is 0.3, and 8 minus 7 is 1. So this just gives me negative 0.1. I didn't even need the calculator, even though it was a calculator problem, but not a bad idea to use it on stuff like that so you don't do something really weird. But of course, we could have left it like that as well. All right, but then I need units. My units, it tells me, and I probably should have written this up here as well. This is, so it says velocity in miles per minute. So this is miles per minute, and these are minutes, right? So when I'm back over here, my units, the numerator was velocity, which is miles per minute, and my time was minutes, and we can just leave it like that. Okay? Everybody okay with all that? All righty. Let's look at B. B says, using correct units, explain this meaning in terms of Karen's trip. Find the value of this right here. Okay? Now, when I take the absolute value of the velocity, I get something different than if I don't take the absolute value of velocity, right? Because here, if I don't take the absolute value of velocity and I do this accumulation, these two cancel each other out, right? Because I ended up back at home. If I take the absolute value, then this part that's negative becomes positive, and then I get the entire distance traveled. Does that make sense? Now, let's go back to this one real quick. Because here, we said without the absolute value that this is the total distance traveled, right, instead of the displacement. That was okay because it says we always have a positive velocity. If your velocity is always positive or always negative, then you're going to get the same thing whether you take the absolute value or not. Does that make sense? I mean, when it's always positive. So that's why here it didn't have the absolute value, and that was okay, and it was still total distance when we wrote it. Here, because it's absolute value, it is the total distance. Okay, and then we're going to find it. So we can say the integral, and I forgot what it said again, 0 to 12, absolute value, v of t dt is the total distance Karen traveled, or Karen rode her bike. I mean, you can write it however you. The total distance Karen rode, let's just do that, or whatever you wrote is fine, rode in what units? Miles. Okay. So V is the total distance Karen rode in miles from t equals 0 to t equals 12 minutes. All right, so then I want to actually find that. And so when I integrate 0 to 12, absolute value, v of t dt. Let's go find those. How do I do that from this graph? What do I have to find? Areas, right? So let's find these areas. This area is going to be 1/2 the base. What's the base? 2 times the height. So half of 2 is 1 times the height is 0.2. Okay? So this is negative 0.2 right here, but we're really using the 0.2 up here, so you can kind of think of it however you want because we're making it the absolute value. Then we can chop these up because I know y'all are going to chop these up probably in weird ways, but where would you make your next chop? It's 6. Okay. Here it's 6. It's going to be 1/2 the base, which is 1, times the height, which is 0.3. What's half of 0.3? 0.15. Or, to be safe, you can put 0.3 over 2, or you could use your calculator because it's a calculator question. Either way. It's 0.15. If I have 15 cents and I double it, I get 30 cents. There you go. So I'm making sure I was right. Y'all make me second guess myself sometimes. Where would you make your next chop? 7. Okay. Then this is just base times height. 1 times 0.3. This is 0.3. So I got 0.3, 0.15, 0.2, 0.2. Then what would you do? You can do would you do the triangle by itself? I mean, because I can tell you what you can do, but that doesn't mean you're going to do it. Yeah. You can make it into a trapezoid right here. Do you have 2 trapezoids? Are they turned the same way? No. Okay. So here, these are the bases, and this is the height. On this one, these are the bases, and this is the height. Or you could chop up that little triangle, like whatever you want. But this right here, this part right here would be 1/2, and then you add the bases. So this is, what is it, 0.2 plus 0.3 times the height, which is 1, right? So 20 cents plus 30 cents is 50 cents, and you take half of that, and you get 25 cents. But I'll remind you again, this is a calculator question. I'm going to make you use your brain right now for this part, because Yair's asleep, so he needs to use his brain. Okay. Then here, we get 1/2. We add the bases. This time my base is 1, 2, 3, plus this base, which is 1, 2, 3, 4, times the height, which is 0.2. Okay. So this gives me 7 times 0.2. Half of that is 0.1. So what does that give me? 0.7? Or you could have chopped up the little triangles. You could chop that up differently. Whatever, okay? But I'm going to go down here. We're going to add them up. And I think, so I'm going to have 0.2 plus 0.2 plus, what's next? Because I can't see it. 0.15. I appreciate all your participation. Plus, what is the next one? 0.3 plus 0.25 plus 0.7. Yes? Okay, thank you. And then, what are my units? I integrated velocity, miles. Okay. I integrated velocity. Had it been I was looking for average velocity, and I had like 1 over b minus a out here, which I do not. Then it would be, when I integrate that, I get miles, and then I divide by the minutes again, but that is not what's happening. So just want to make sure you understand the differences there. All right, C. Shortly after leaving home. Oh, it wasn't her ID. She left after all. Shortly after leaving home, Karen realizes she left her calculus homework at home. And she returns to get it. Yeah. That's even funnier than your ID, isn't it? At what time does she turn around and go back home? Give a reason for your answer. 2 minutes. Okay? All right. So we can say, Karen. And one reason why it was easy was because we had already talked through it. Like at the beginning, we thought about all those things, even though nobody had asked us about it, so we can kind of make sure we understand what's going on. Okay, so Karen turned around at t equals 2 minutes because she left her homework, but the reason we know it is because her velocity did what? Okay. Changes from positive to negative. Alrighty. D. Larry has entered the picture. I know. Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by this function, where W of t is in miles per minute, just like hers was. Who lives closer to school, Karen or Larry? Show the work that leads to your answer. So, what do we need to figure out? The total distance he rode, right? So I need to integrate from 0 to 12 W of t dt. Okay, so that means in my calculator, where do I go in my calculator? Now, there's two different things I could do. Since it looks like this is the last thing I have to do, I don't have to put it in a graph. I could just integrate without putting it in a graph, but if you put it in the graph, it's kind of like when you store something. If you accidentally hit wrong buttons, you don't have to go back and retype in all the nonsense, right? So let's go ahead and add a graph, because that's the good way to kind of get you into making sure you do this correctly. So I'm going to add a fraction there, and I want it to be pi. Oh no, it's right. I can't. I thought I couldn't get to it because of the pause button. Pi's down here by the H. Pi over 15, and I'm sure y'all are way faster at this than me because this board makes, what is wrong? 15, okay, times the sine of pi over 12. No, I don't know why I keep getting an error. It's probably because of the board. But are y'all getting errors, or is it just me because of the board? Just me. Huh, shocking. Just me. X. And that is it. Okay. So that's basically what my graph looks like. Do we all have the same thing? Yeah. Do we really care what it looks like? We don't really care what it looks like, right? Okay, but can you tell me this? Does it look like he had to turn around and go back home? No. All right, but that's not really what they were asking me anyway, but, oh, I haven't added it yet. So now I'm going to add a calculator, control doc, right? And I'm going to add that calculator. Now, there's two different ways to get to the integral. What did y'all prefer, the menu or the little button by 9? The button by 9, okay. Button by 9, I'm going to integrate from 0 to 12. Now, we called it W of t in the question, but where is it really? F1, yeah. F1 of x. So see, here I could have just typed in that sign stuff, but dx. You get 1.6. Okay? We all good so far? So we get 1.6 miles. All right, so then we also need the integral from 0 to 12 of v of t dt. Do we already have that? Do we? We sort of do, right? Now, we didn't add all this together because we didn't have to, okay? And in this part, let's say we added it wrong, then it wouldn't have mattered because we didn't add. But now I kind of need it added. If you add all that up, what do you get? You have a calculator in front of you. You don't have to do it. I know, I'm asking so much. $1.8, okay? So that's really 1.8, which I don't know in the real thing, I'd write it up there. But is that what this is asking me for? No, these are different, right? What does this include that we don't want to include? Yeah, her trip back home, right? So really what this is equal to, and you wouldn't have to write this, but I want you to think about this. This is equal to the integral from 0 to 12 of the absolute value of v of t dt minus that 0.2, right? Because we'd want to take that off. So this is 1.8 minus 0.2, which gives me 1.6 miles. No, it doesn't. Wait. Why do I have 1.4 on here? Oh, duh. I have to subtract off. I don't even have that written on here. It just occurred to me. Yeah. Where do I really want to start? Like, here she is. She's at home. She leaves, she turns around, she goes back home, and then once she's here, she changes, and this is her home again. From here there, that's how long it is to get to school. So not only do I have to subtract this out that I put here, but I also need to subtract that out because basically she left her house twice. Does that make sense? Like if I walk down here, and then I turn around and I walk back, and then I walk all the way to the wall, I can't just take off the part from here to here because I went back and forth. She's at home, she leaves, she turns around, she's back at home. The distance from her house to the school is from here to the end. Well, she's just at home. So technically she leaves here. Yeah, you're right. She's here. She technically leaves here. That's 0, so it wouldn't affect anything. Yeah, she doesn't leave before she leaves. So it's minus 0.2 and then minus 0.2. Oh my God. 0.2. This gives me 1.4 miles. So see, if you don't do that right, then you get the wrong answer about who lives closer, right? And so your work shows all that, and then you can say, who lives closer? Karen. Karen lives closer to the school. We good on that? What questions do you have? That's it? All right. Do you have any blank space on any of these? Probably not. What about the first page of stuff? No? Not really. Maybe at the bottom of this. Okay. Wherever you want to put it, but you should at least, we're not going to need tons of room, but if you can find it here. Oh, yeah. Well, then you can use the top. Since we have a little bit of time, I want to, yeah, we're doing more. We're not done. Okay. So we have, all right, a particle traveling, blah, 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 right? Particles traveling along whatever. And we have the velocity function, v of t equals 3t squared plus t plus 1. And we want to find, so we're going to do two things, and we're just going to set them up, okay? We want to find average velocity on 1 to 3. And we're going to find average acceleration on 1 to 3. Okay? But like I said, we're just going to set them up because we're going to look at how the setup is different than what it's asking us for. Okay. Velocity, I want the average velocity. Average rate of change, or, because average, but velocity is the rate of change of what? Position. Velocity is the rate of change of position. So I cannot just do straight up the slope formula, right? But if I integrate from 1 to 3, if I integrate the velocity function, dt, when I integrate velocity, it gives me the accumulation of the position, right? And if I want average velocity, and I don't have information about the position, then I put this 1 over what? 3 minus 1. B minus A, which is 3 minus 1. So average velocity, I can integrate velocity and then divide by the change in time, right? Average acceleration, I could do the same thing, but with acceleration, obviously. And I have the velocity function, so I could find acceleration. But I don't have to do this. So basically, there's two different ways I can do this. I could do 1 over 3 minus 1 and integrate from 1 to 3 a of t dt. Or, because I actually have this enough information, acceleration is the rate of change of what? Velocity. So, or I could do v of 3 minus v of 1 over 3 minus 1. Right? Does that make sense? And here's what would happen. If you took the derivative of this is easy to do. A of t, that's going to be 6t plus 1, right? So if I take the derivative and then I integrate it, guess what? I'm just going to get this right back, and then I'm going to evaluate it from 1 to 3 and divide. I'm basically doing that anyway, okay? But we have to know how to do this because we don't always have the information that we need. You with me on that? Okay, so do you see the differences there? Okay, you don't always have this choice. We did here. Here we do not, okay? What questions we got? We good? Okay, perfect.